Hello, everyone. I'm Miss Gian, and today we're going to talk about something that might make some of you groan a little bit. We're going to talk about statistics. Pero before you tune out, hear me out. This is not, we will not be torturing you. I will not be torturing you today with formulas, computation. We don't do manual computations. We have tools naman. So what we are going to do is refresh ang sa concept so that we understand the theory behind it, and also so that you know what it means when you're actually navigating through the tools that we will use today. I searched it up and there's an alternative for SPSS, which is PSP, I guess, and there's also a 14-day trial for SPSS. Anyway, more on that later during the phase 2 of our subject. I'll teach you how to download the tool so that you have an idea of how everything works. But yeah, let's proceed to a refresher on statistics. So I'll try my best to make this as less painful as possible. So right now, you know that we study statistics, but why do we always study statistics in psychology? What's the use of it? So your position is a test taker. So you get a score. So example, if we have quizzes, we have exams, you get a score, right? So you either celebrate it if you get high scores, and you don't celebrate if you get low scores, and then you move on. But in the future, you're a psychologist, you're a psychometrician. Now, you're already a test user and you're the ones that's interpreting those scores. So you'll be the one telling your client what their IQ means. You will interpret nonverbal behavior of the person you're talking to assess whether there are any abnormalities or at extreme ends of what is average than the normal population. When you look at it that way, you have a huge responsibility. You are a consumer. You're no longer a test taker. You're the one that's administering the test, and you're the one that's conducting assessment. Remember again, I keep on reminding you this, we're handling human life. And test scores, although they're sometimes we can just say, well, they're just numerical numbers, they influence everything. They influence our career paths, diagnosis, educational placements. So someone's life, for example, might literally change direction based on how you interpret a number. So, for example, you've all undergone the screening for being placed in or having a slot in psychology, diba? First, you will submit the requirements. A person will screen that out if you pass it through your grades. And then after you pass that screening, then you answer an entrance exam. And after entrance exam, if tako mo score, maka-pass through din mo sa interview. So, di ba, nga naman na, that's a form of assessment, no? Educational placement or the educational assessment for you to have a slot sa school. Now, kamo in the future, kamo mo administer the test, kamo ang mo interpret, kamo ang mo decide whether or not you accept that student applicant sa school. So you literally have an influence on someone's future or someone's path. So that is a big responsibility. So, and lastly is, aside from the first and the second, is that tanang measurement, it contains error. And dili man ta kaingon good ng number na itong makuha is precisely measuring what we want it to measure. So it's just an approximation. So we cannot really say, an example, ang atong anxiety score or anxiety level is at, say, 45 over 100, right? That is not the precise number. There is some form of error in a way. So what are the errors here? Could be the selection of the tools jud mismo has the error. The items there could maybe not be relevant to the population. Remember, there are items that is highly influenced by contextual factors like culture. Unsa pa na? Could be the weather as well, diba? Remember our example sa mga kanding na mga exam? Also applies to persons, right? To people. Example, if katong nag-quiz mo sa stairs, diba? Unsa may error possibly ato? Katong mga nag-pass on your side, could be an effect, could be a measurement error. And nibalhin dayon og room, diba? So that's another form of error. So dili gyud na mawagtang ang error. Every single test score has some uncertainty baked into it. And what's the role of statistics? Statistics help us understand and account for this uncertainty so that we don't make decision based on the illusion of precision, right? So let's review the scales of measurement. It's a foundational concept in psychology. And later on, when you have a career path as statistics, you will encounter this again and again. Interrelated ni siya manggod kung unsa na statistical treatment imong i-apply sa certain data set depende sa iyahang type of scale or level of measurement. So whenever we assign numbers to things, we're following certain rules, and depending on those rules we can do different things with those numbers. So here's a easy way to remember all these four levels. Noir, like the French word black, NOIR. So each letter, they stand for a scale, and they go from the simplest to the most sophisticated. In terms, when we say sophisticated, meaning daghan kayo siya statistical tool na ma-use because of the type of data set. Daghan, bali, statistically easy to manipulate siya ba na data. So, kuan ni sila iyang characteristics on top of each other. Mo nang gitawag siya levels of measurement. So, let's start sa nominal. No? Nominal are just plain categories. Example, aning gender, diagnosis code sa DSM, sa pa, your learning, or your study type, or sa mo, night owl ba mo, or morning person, yan na mga categorical data. Ordinal is nominal, which pero ordered siya. So it's a nominal data, but ang difference, ang na-add on na characteristic, it is ordered. There is a meaningful order. So mga example ani, class rank, Likert scales, kato kung gipa-answer na Rokich value survey wherein you will rank your most important to least important na values. That's one. Unsa pa? Educational attainment is also an ordinal scale of measurement. And then interval is having the characteristics of both nominal, ordinal, and then unsa man siya ang iyahang characteristics na wala sa ordinal. Ang ordinal, dili ka ka-determine na ay equal distances between the numbers. So kaning interval na siya equal distances. Ang ratio is having all the characteristics of nominal, ordinal, and interval. Ang difference na niya sa interval is ang ratio na siya true 0 point. Ang interval, arbitrary ang iyang zero na value. So sa example, ano sa meaning anang arbitrary ang zero na value? Example, kung na tag age. Kung nabay number zero sa age, di ba, we cannot really say that kay having a zero na age does not really indicate na wala kay age. So inga na siya, no, dili siya, wala siya true 0 point. A ratio, on the other hand, is not siya true 0 point. So sa example, ani, kilograms, force applied. So usually, makabantay mo, ang ratio ng mga scales, usually siya mga construct siya under pure sciences. Pero dili tanan. For example, temperature. Temperature is considered interval scale because zero does not really indicate that there's no temperature. It just indicates na, ano na siya, no? If after zero, below freezing point na siya. Hope that's everything. Hope everything's clear. So let's look at the first two levels more closely muna. Let's look at nominal and ordinal. Okay? So, nominal scales, they're the simplest. So, they're just really labels lang gina siya, categories na walay inherent order as mentioned previously. So, again, example ani is mga DSM diagnosis codes, mga yes or no survey responses, categories sa gender, female, male, asa ka nagpuyo, sa Lapu-Lapu, sa Cebu City, sa Guadaba. So those are categorical. Okay? And how do you interpret or describe the data? The only statistics that you can use is frequencies and percentages. Okay. An ordinal scale is, again, categories having the characters of a nominal scale, and there is a rank order. Pero ang iyang intervals is unknown siya. So sa example ani, mention ako ani no, Rokich value survey, job applicant rankings, and mga wait lists sa therapy. Unsa pa, educational attainment, age is an ordinal scale because there is a meaningful order to age. Okay, so next. So unsa may difference sa ordinal ug interval data? Sa ordinal, kibaw ka sa order pero wa ka kibaw sa distance between the ranks. So example, sa Likert scale, di makakaingon na ang distance sa 1 sa 2 is equal sa distance sa 2 ug 3. Kung manatag 1, di ba, you say, for example, you strongly disagree, and then 2, you disagree. Is there any true distance sa values sa 1 and 2? Wala siya. So mana siyang ordinal na siya na scale. And Alfred Binet also contend na Alfred Binet is the one who developed the first IQ test, and he made the exact point. He said, now, we do not measure, in psychology, we do not measure, we just classify. And he understood that his intelligence test scores are ordinal in nature, dili siya interval. Let's move to the interval and ratio scales. Statistically speaking, these two levels of measurement are considered the more powerful scales. Because again, daghan kag ma-use na statistical treatment nila, daghan kag ma-use na tools nila. Example sa mean, di ba? Dili makaka-mean og ordinal na data, wala man na siya value. Pero sa interval scale, maka-create tag, maka-compute ta sa mean, maka-compute ta sa SD, maka-compute SD meaning standard deviation. You will learn about this one later in the next few slides. Anyway, unsa ning interval scale? Ang difference between 80 and 100 sa IQ test is the same difference between 100 and 120. So, unsa man ang kuan niya, ang number niya, 20, di ba? So, 80, 180, I mean, 100 minus 80 is 20. Then, 120 minus 100 is 20. So, pareha siya score difference sa duha ka scores, no? Sa point A, sa score B. And this is quite huge because it means we can, again, as mentioned, we can calculate the mean or we can calculate meaningful averages. But the thing with the interval scale is wala siya true zero. Ang IQ of 0, for example, doesn't mean na zero intelligence ka, meaning non-existent imong intelligence. No. Or dili siya, wala siya true 0 point. Kung manatag zero imong IQ, that does not mean man na you don't have brain power. So, ang 0 point again sa interval scale is arbitrary siya. And compare it to ratio scale, ang difference lang gid sa duha is ang ratio scale na siya true 0 point. So everything that the characteristics that the interval scale has, plus a true 0 point. So the number 0 there really has a meaning. It's not arbitrary na. So for example, time. So someone who completes a puzzle in 30 seconds took exactly half the time of someone who took 60 seconds. So there are meaningful comparisons already between the numbers. Okay, so for example, what else? Grip strength. 0 has a true 0 point. Having a 0 grip strength, meaning wala kay grip strength, right? 0. So weight in kilograms, right? 0 in weight, meaning wala kay weight. Naagid siya, naa siya kanang true meaning ang yang 0. Naman ako, if ang inyohang weight is a person's weight ratio or interval scale. So, I know it's kind of confusing, di ba? Because nagitaw na walay weight. Pero, dili maguna igana na pagka-philosophical ang pagka-debate no, sa interval and ratio scale. Ang imong tanawon, if naabay true meaning ang 0 niya. So, the 0 equals to 0 weight? Yes. Di ba? So, mao na siya. Ang weight is under siya sa ratio scale. And you might notice na most psychological tests are technically ordinal siya. Pero, researchers and data scientists often treat them as interval. Nga naman, even if ordinal siya, we classify or when we are treating we're treating the data, it's considered interval because it lets us use more powerful statistics. Okay, so just be aware of this one when you're interpreting results. Alright, let's move on to describing data. So we'll cover frequency distributions, also measures of central tendency. So first, atuta sa frequency distribution. Now, if you have a bunch of test scores, sample kani, how do we make sense of them? Especially for ordinal nominal data, they're best presented as frequencies because wala ay other statistics ang pwede ma-use niya. So, a distribution is, unsa din ang distribution? Ang distribution is simply a set of test scores arranged for study. And ang raw scores, they are the unmodified original numbers. So whatever you get on your test scores, if you put that on the Excel sheet or if you put that on the sheets sa SPSS, those are the raw scores. Now, one way to organize your data is through a frequency distribution. So, unsa ni siyang frequency distribution, enlist nimo kapila ang nakakuha gigana na score. Now, it depends on the type of or how many numbers of sample you have on what to use. Is it better to use simple frequency distribution or group frequency distribution? So, ang kani siyang simple frequency distribution, this is better suited for small data sets. Ang iyang advantage ang nice sa simple frequencies, makita gyud nimo ang detail niya, right? Kung pila nakakuha sa 1, 2, 3, 100, pila nakakuha 99. Pero overwhelming na siya once you have over 100, 500 samples. That's why we have group frequency distribution as a solution to that. Instead of listing every score there is a test and how many got it, Ang buhaton ani is through class intervals or score ranges. How many people got a score between 95 to 99? There are two, right? So unsay trade-off ani niya, it is easier to read, however, mawagtangan siya detail. Okay, of course, clumped together man ang scores. Okay, so mana siya ang frequency distribution. Next, let's move on to different graphical representations. Now, numbers are great, but sometimes we need something to visualize it. So let's talk about the three ways and how we visualize frequency distributions. First, we have the histogram. This is vertical bar siya. As you can see, may pagkapareha siya sa bar graph, pero ang histogram connected siya no, with each other. Now, for the histogram, ang height niya shows the score. Rather, sa gani, ang the bar on the kani siya shows the score. And ang iyang height shows the frequency, kapila siya. Okay, so igana siya ang histogram. And say key feature niya again, the bars touch each other, so meaning contiguous siya. And this is best used for continuous data. So interval ratio data. So ang bar graph, best used siya for categorical data. So for kani siya no, mga nominal data. So the same as a bar graph, ang histogram, ang difference lang niya is na siya space in between, and better suited siya for nominal or categorical data. Ang x-axis, which is the abscissa, is diri butang ang categories, and then y-axis is for the frequency. Okay, and next we have the frequency polygon. So instead of bars, we now see lines. Okay, we see plot points, and then we connect them and they form a lines. Now, overall, it's great for seeing the shape of your distribution. Makita na to, is it peaked? Or is it like a normal distribution? Or is it skewed? Is it positively skewed or negatively skewed? Okay, so again, ano siya, no? So if I haven't mentioned already, the x-axis is the abscissa and the y-axis is the ordinate. And you might see this in the textbooks. In some of the textbooks, so it's better na you know that they're pertaining to these words, x-axis and y-axis, if they use abscissa and ordinate. Okay, now we got to one of the most important concepts in statistics, also in psychology statistics, the measures of central tendency. Usa na siya? It's about finding the midmost score, the center of a distribution. So usually you know this as the average, pero in more technical terms, we can find the average through three different ways or three different measures sa central tendencies. We have the mean or the arithmetic mean, computed as the summation of all scores divided by the total number of the sample. So kani siya is a Greek word ni siya na sigma. It is the symbol for summation. So summation of all the raw scores, x without a bar, divided by the sample or total number of the sample. So we also have the median, which is the middle score. So what you're going to do here is imong i-order tanan ang score. Example, di ba, naamoy Excel sheet. Inyo ibutang inyong scores there tanan, 100 ka buok. Inyo na siyang i-sort from highest to lowest. Itaon ninyo ang tunga, which is 50% from di taas, 50% above, and then also 50% below. Ang kana na tunga na score, that is the median. And this is best for ordinal data and skewed distribution. Now, for the mode, no, it's looking at the most frequently occurring score. So there are chances wherein naatay gitawag na bimodal, meaning in a certain data set na ay usa ka score na pareha sila na both have the same numbers on how they occur. Okay? So example, itong i-draw. Example, ana na siya, no? So example, ana, and then ana. Ana na siya. And then example kani siya na score is 5/10. So dagan na nakakuha 5/10. Say 7 kabuok students, and then diri kay naay 9. So kani siya kay 7 pud kabuok students ang nakakuha 9. So that's what we call a bimodal distribution. This is looking at the frequency of a score rather than computing it. Again, so for you to really find out unsa may dapat gamiton, you look at your data type. It depends man gud on your data type and the distribution shape. So normally for skewed distributions, dili gamit ang mean. Sensitive man gud na siya sa mga outliers. Sensitive na siya sa extreme score. Unsa man, I'll let you visualize that. For example, na ay 2, 3, and then ay 4 na nag-score pod, and then out of 10 na apoy naka-score og 10. So say for example, kaning score sa 10 ka buok ay sa 4 ka students, kung imo na siyang i-mean because there is an extreme score, dako noon siya og average compared than what is really the average of a normally distributed data set. Kaya I hope that's clear. So ang kaning mean gamit ra gyud ni siya if normal ang distribution sa imong dataset ug imong data type is interval or ratio. Ang median is for ordinal na data and then skewed ang distribution. Ang mode is for nominal na dataset and ganapog ka mo tanaw qualitative analysis no kanang magkuan ka mag-coding ka kapila ni siya giingon na number gana siya. So naa siya designated or appropriate depending on your dataset. So let's look at the Bruce dilemma. Okay, so in terms of hiring decision, example HR mo, and then naay murag work sample that the applicant needs to undergo, and it's a requirement wherein they need to type at least 50 words per minute, and they're gonna undergo 7 trials. Okay, so if you're the HR, you're gonna use mode or are you gonna use mean? So remember, when do we use mean? Diba? When our data is interval or ratio. Right? And when do we use mode? If our data is nominal. Is this nominal data? Diba? No. So, na natay X criteria. So, the obvious answer is mean. Because if you look at the numbers, wala raman sad siya extreme score. Okay? So, we only use mode and median if the distribution is skewed or if it is not an interval or ratio data. So, I hope everything's clear. Okay? Normally if you research and you have this kanang numbers, right? Unsa jud permi gamiton, permi jud ta magamit og arithmetic mean. Very rare jud kayo ni siya na magamit ang mode or median. So, ang central tendency tells us about the center. Pero if for example, it's possible na ang duha ka groups or duha ka distribution is same siya mean pero lahi siya og dispersion. And this dispersion is what we call variability. So, padalitan ka ni siya. Ang iyang scores, butang talang in a sample, there are 2 test takers na nakakuha 0, na nakakuha 100. If you calculate the mean, that's 50. And then if there's another group wherein ang one person nakakuha 40, ang the other nakakuha 60, then if you calculate it, the mean is also 50. But if you look at the dispersion of the two, you would see na ang first distribution is highly dispersed, meaning lagi kayo siya kanang value no sa each other compared to this distribution wherein tightly clustered siya. Now you might be wondering, why are we talking about dispersion or usam gid yung value sa variability, especially in inferential statistics or psychology statistics? For one, there's a lot jud. Variability is like the bread and butter in psych stat or inferential stat because it affects a lot of things. If you have undergone inferential statistics already, so you know na matter siya sa pag-calculate sa ANOVA, sa t-test. Pero also, it matters because it affects how we interpret or infer about our results. So if tightly clustered imong distribution, mas makaingon ka na imong estimate of your inference is more precise than a widely dispersed distribution. Ang dispersion man good or variability accounts for or represents random error. I would like to repeat it. It represents random error. Now, lahi man na siya ang kaning random error, no? The error, iso da iko ana ni. Basta error na siya ha, error. Unsa na siyang random error? Ang una is individual difference. Ang next is measurement error. Sample, error na naa sa tool. And then ang next is uncontrolled factors or mga variables like the weather, test taker anxiety. So, variability accounts for that error. So, of course, if grabe or tako ang variability, mas dako ang error. So, mas less confident to say na the results that we get is we can infer na maog yun na siya ang results sa ato ang sample. Hope that's clear no and we're not running in circles. Well, anyway, there are 3 measures of kanang variability. We have the range, we have the interquartile range. So, unsa na siya ang range? It's the simplest measure. Okay? So, it's just the highest score minus the lowest score. So, unsay bati niya is simple pero sensitive po siya sa extreme scores. Now, a better option of range is the interquartile range. So, unsa ni siyang interquartile range? It's the spread of the middle 50% of the scores. And compared to range, mas less affected siya sa outliers. Alright? So, kani siyang duha, rarely ra kay mo makasugat ani kung mag-compute mo sa inyong data sa statistics, no? So, i-treat ninyo inyong data, rare ra kayo makasugat og interquartile range. Ang per ninyo masugatan is SD or variance, okay? Standard deviation. So, unsa na ang standard deviation? It tells us on average how far scores fall from the mean. So, ang formula is this one, no? S equals to the square root of the summation of x squared over n. So, di ba, intimidating siya. So, ang meaning lagi ani na formula na is imong i-square ang deviations, i-average nimo, and kwaon nimo ang square root. So, conceptually, it's just asking how spread out are the scores? How dispersed are the scores? Are the scores from the mean? And if you square the standard deviations, you get the variance. So it's the same information, it's just in different forms. Okay? So nganong kasagaran square man no para dili ta makakuha og negative values. So kana lang sa ato ang i-discuss here kay refresher naman lang ni siya. Alright? So let's move on. So let's now look at the distribution shape. Diba, in the previous slide, I keep on mentioning about a skewed distribution. What I'm pertaining to is this one, no? A positively skewed distribution and a negatively skewed distribution. Okay, and we will also discuss in this slide kurtosis. But let's go first sa skewness. Okay, ang skewness, it tells us about symmetry or the lack of it. So when we say that the distribution is skewed, meaning dili symmetrical ang distribution. Dili siya Gaussian curve. Di siya bell curve. Okay? Basta bell curve na siya. Okay, so unsa ni ang positively skewed distribution? Do not be confused kay normally ani is if P tanawa mo ni siya ang pagkuan ang technique sa pag-memorize. Letter P siya na naghigda, meaning ana daghan ang nakakuha og low scores kay naman sila diri sa left side of the tail. Now if ang distribution is negatively skewed, asiya sa example mo ni ang mean na asiya sa right side of the tail, so meaning daghan ang nakakuha og high scores. So unsay possible na ma-infer nato ani. So if positively skewed ang distribution could be that the test is too difficult for your sample. Panalitan naghatag siguro kag calculus test sa usa ka sa elementary, so or sa kinder, di ba? So daghan jud makakuha na nilang mga 0, 1 or 2, di ba? So and then ang negatively skewed is sayon ra ka imong test or nagprepare ang imuhang mga students or imuhang sample, di ba? Or mga bright lang yun sila, manadaghan kayo sila nakascore na dagko ilang score. So, mana siya ang meaning sa skewness. Now, mana ta na, if we hear the word skew, and ikaw pod as, if you are a statistician or a psychologist na nag-research, baka nungogay kag skewed imong distribution, makaingon ta na bati sometimes or abnormal nga naman. Kasagaran mo ko sa statistic, mag-require siya na ang imuhang distribution is normal. So normally distributed imong sample dili skewed. Kay if skewed imong distribution magamit kag alternative test ana. Okay, so mo na siya maingon ta na if na siya connotation ba if na skew ang distribution mo ana data na kanang bati no, but dili na siya necessarily bati man, it's just simply a way to describe your data. Dili ta moingon na kanang kung skew bati nanday mo dita, no, that's just really a description. Pero naala siya connotation because of the statistic that you will use if you have a skewed distribution. Right? And then let's move on to kurtosis. So kurtosis is it describes the peakness. So unsa ka peak ang imuhang distribution. So let's go over here. Kay katag na ang naong sa pikas. So peakness ni ang kurtosis. Dira kay ta mo deep dive ani kay if we do a deep dive, complicated na kayo siya no for advanced ano na ni siyang kurtosis. Let's just look at the description. So managitag leptokurtic, meaning very hait siya, not very peak, narrow peak ang imuhang distribution. And then manatag mesokurtic, meaning normal ra siya. So a normal distribution or a Gaussian curve has a mesokurtic kurtosis. Okay? And then manatag platykurtic, meaning flat and spread out. Now, for you to remember this one, think of a platypus na naim nag-ambak-ambak. So ang nag-ambak-ambak, leaping, meaning leptokurtic, taas ug ambak, narrow peak. Then platykurtic, flat and spread out. Alright? Okay, so we go over to the star of the show, which is what I always talk about, the normal curve. So it's also called the bell curve or the Gaussian distribution. It's named after one of the mathematicians who developed the curve. Okay, so unsay characteristics aning bell curve? Well, bell-shaped siya, and then ang iyahang mean and median and mode, they're all at the center. Okay, so meaning iyahang kung ano kuha siya central tendencies. And then ang tails approach but never touch the x-axis. And it is defined mathematically by mean and SD. So, why does the bell curve or the normal curve matter in psychology? Because if you try to get all the data of intelligence test scores, personality measures, achievement scores, they form a bell curve. Okay, so theoretical po siya. And on real life, makitaan po nimo ni siya na shape. So, man siyang magic number na you need to remember, 68.26, 95.44, and 99.74. So, say meaning ani niya? At 1 SD away from the mean on both ends of the tail, you captured 68.26% of the population. At 2 SD, mali siyang SD. At 2 SD away from the mean on both sides of the population, that's plus minus 2 SD, that's capturing 95.44% of the population. Now at 3 SD, that's capturing 99.74% of the population, right? So, kanina mga percentages, it instantly let us know where any score falls in the distribution. So, for example, naa siya sa kanina kuan na kanang distribution sa example, mo na ta na, pila man ang score ni Einstein, naa siya sa plus 3 SD. So, na siya diri. So, meaning na siya sa higher end sa tail. So, taas di kayong score si Einstein. Ano siya. So, to help us understand more about the Gaussian curve, I have here a question. So, panalitan, naatay distribution, right? And on a typical IQ test, wherein the mean is 100 and the SD is 15, an IQ of 70 falls at negative 2 SD. Okay, so let's use a marker for this. So negative 2 SD and an IQ of 130 falls at a positive 2 SD. What percentage of people score between 70 and 130? So balik ta. Sa kani. So ningon to, di ba, na positive 2 and negative 2. So, tanawin mo, ang question is, pila ang percentage sa people na na-fall under these values? Okay, this is the SD. And you look at this one. Ana. Okay. So, pila din ni siya? Tanan, kani. Pila ni siya? So, if you answered 95%, you are correct. Okay, so 95% ang answer. Now, follow-up question. For people na ni-score at either ends of the tail, sample si Einstein, and example si, kisa mga ito example diri. O, butang na lang ta si Gian, ako, nakascore ko diri sa negative 3 SD, me, and then si Einstein here. Masa may implications for people who scored here and here? Meaning, kanina percentage at 2.15% on the lower and higher end of the tail, or the left end or the right end of the tail. What does that mean? No, so possible for someone that's scoring at the left end of the tail, they might have difficulties. They could be clinically diagnosed as having an ID or intellectual disorder. And for someone that's scoring at the right end of the tail could be a genius, right? Good gifted individual. So i-hire na sila sa paonday na sila sa mga first world countries to invent kanang nuclear bombs. I'm just kidding. So inga na siya, okay? So far, we've been talking about raw scores, katong mga previous slides. Now, let's move on to standard scores. Usa din ni sila ang standard score. When we talk about standard score, it converts the raw scores to a common scale. So it gives context. That's as simple as it gets. It gives context to the raw score. Because say for example, I have a raw score of 54 sa psych assessment in an achievement test. And on theories of personality, I have a raw score of 64. Diba? On the first sight, ana niya, mukha na ka, asa man dito ang mas dako, diba? Ang imong score sa TOP, which is 64. Pero if you compare it relative to other scores, that's an entirely different thing. So that's where Z-score, T-score, STA9, and IQ scale enters. So these are what we call standard scores. They solve this problem by converting the raw score, katong 54 or 64, to a common scale. And they tell you exactly how one fared the test, or how one fared the test relative to everyone else that's taking the test. Okay, so that's the purpose of standard scores. Now, pinaka-basic is ang Z-score. Ang Z-score, na siya mean na 0 and na siya standard deviation na 1. So, if you want a visual of that, go over page 111 sa ato ang material. And there you can see the differences between the scores, no? The Z score, T score, A score, and IQ score. Okay? So, ang formula ana kapag compute sa z-score is ang raw score, which is the x, and then kaning x bar, which is the mean. So the raw score minus the mean over the standard deviation. And then once you compute that, you can plot right away asa siya na fall under. So ang range niya is typically -3 and +3 SD. Okay. And then T-score, they're similar, pero the mean now is 50 and then the SD is 10. So, imbis na 0, 50 ang nasa tunga. And then, ang iyang deviation, imbis na 1, di ba, ang SD is 1, 2, 3. Ang kani siya, 50, 60, 70, 80. So, igana na siya ang iyang, kung ano man yung meaning sa SD, di ba, ang dispersion niya. So, usay positive ani niya. Unlike sa Z-score, na magoy negative numbers ang Z-scores. Ang T-score, wala siya negative number, so it's easier to compute. Kaya if na kay negative na number, sa math na siya murag technicality, so it's very cumbersome in computation. Now, ang stand nines is, from the word nine, it divides the distribution into 9 categories. Mo na siyang standard 9, stand 9. So, they're whole numbers from 1 to 9, and the average is 5. The average or the mean is 5. So usually this is used in achievement test or scholastic achievement test. And then of course we have the IQ scale, which is bukang bibig from the first chapter pa lang. And the mean of that is 100 and the SD of that is 15. So usay other examples ani kay SAT is also an example of IQ scale, pero iyahang mean lang is 500 and iyang SD is 100. So again, for the visualization of the differences between them, look over page 111. And also, please bring a calculator during our rationalization because we will be computing, we'll be transforming a z-score to t-score and vice versa, okay? So if for us to really test out our knowledge, I have here a problem. So suppose, kato siya akong example is katong 6454, right? So look at Crystal. Crystal scored 24 sa reading and 42 on the arithmetic. And if we convert them to a z-score, so again, if you want to know how to convert a z-score, you can look over sa material and then it teaches you how to perform it. But to be clear lang, here's the formula. Z equals x, this is the raw score, minus x bar over s for the standard deviation. So this is the, ang noun niya man yung noun kung sample ang imong gikuha. Kung population gali is x minus mean, ang mean niya mar siya u over the SD. Okay, so same na sila sabot. Okay, so say for example, si Crystal na ay 24 sa reading. Sa pag-compute niya, nakaproduce siya z-score sa iyahang reading, which is plus 1.32. And then sa iyang math, kaning 42 is negative 0.75. Now recall that our z-score, let's go back to the previous slide. So kani, di ba? So 1.32 around here, iyahang reading score. And then negative 1 something here ang iyahang math. So although iyang score sa math is 42 relative to others, she did not perform very well as compared to her reading, which is 24. Okay? So in a sense, z-scores, standard scores, gives context to the score, to the raw score. So it gives us an insight as to how the individual perform relative to others. Mo na gina siya ang meaning or the purpose of having these standard scores. Okay, so it gives us the understanding of our performance relative to others and gives a fair comparison across groups. Okay, so hope that's clear, right? So here's another question. Now, a client tells you, I scored 115 on an IQ test. So is that good? How would you explain their score? Okay, try to pause the video and try to kuan the question no, for you to really engage with the material. So how would you explain their score? First is, what's the mean and SD? Where does 115 fall? So try to compute daw. If, remember, ang IQ score, iyahang mean is 100. So if naa siya 115, naa siya, if imo siya i-convert, ang iyang z-score is plus 1, di ba? So unsa man siya, asa siya na percentage na fall through? Naa siya sa plus 1 SD sa mean. So, plus 1 sa average, di ba? So you would say na you compare, so you would probably say na you performed 34.13% higher than the average population, di ba? Mga nga naman na. So unsa man ang z-score, unsa ang pag-calculate ana, o try to transform an IQ score to a z-score. And how would you communicate that? Di ba, too technical mo, ana you are plus 1 SD of the mean. Di ba kasabot ang most people, ana. So how would you say that? So, ana ka na. Example na ay, ang average population, naka-score og igani, naa ka one stage higher than the average population. So, meaning, sa tanang nag-exam, ang imuhang IQ is one stage. Stage is a common word. It's not really technical. It's not a jargon. So, nga na siya. So, try to practice daw how would you explain that to someone in a plain language where they will understand it. So, let's wrap up. We're done. Our favorite word. So, here are our key takeaways. We've discussed the scales of measurement. No, we have the nominal, ordinal, interval, ratio scales. And then, each level, a new characteristic is added. So magkaano siya. Ano siyang levels of measurement tawag niya, no? Nominal, remember, is categorical. Ordinal is categorical but a meaningful order towards it. And then interval, there is a precise number between the first and the former. No? There's equal intervals between the first number and the second number. That's why there's interval. And then ratio dayon has a true 0 point. So next, we also covered central tendency, no? Katong mean, median, and mode. So each tell you something different about the center of your distribution. Of course, we choose what we will use depending on the data type and the distribution. Usually though, ang gamiton dyan sa statistics is mean or the arithmetic mean. Rare na kayo ang maggamit og mode because it is a nominal statistic. So, dili siya maingon na makompute nimo siya. And then, third, variability. The standard deviation is our go-to measure. It's our gold or bread and butter in psychology and in statistics or inferential statistics. And remember, variability is very important in inferential stat because it teaches us the dispersion of the data. And remember, it also accounts for error. So a higher or bigger SD means a bigger error, right? So when you compute some a scores or a data set's SD, kung dako gali na siya error, so dili kay ta kaingon na precise atong ma-infer or atong insight is precise regarding that sample to the actual population. And then next is our normal curve. No, our magic number is 68, 95, and 99.7 rule. So this is the foundation for score interpretation in psychology. And usually standard scores are in the shape of the normal curve. And fifth, as mentioned, the standard score, the Z, T, STA9s, the IQ, they all convert raw scores to comparable scales. So they contextualize everything. They make the score meaningful. They make us understand the performance of a certain test taker to the other test takers that's taking the test. Wow, there's a lot of tests in one word. Yeah, and the overarching theme of all this is that, remember that measurement contains error. And statistics help us understand, quantify, and communicate that uncertainty. And it's not a weakness. That's just, the reality that everything that we do, there is an error. Dili ta ka precisely measure or capture a certain thing. All we can do is approximation. Right? And I hope you guys learned something. And as always, have fun learning.